Now, when we're retrieving documents from a MongoDB collection, it's often the case that we would like the database to support us in paging through the results. Now here I'm not talking about batching, but rather think about the search engines you've used or a site like Amazon where you do a search for a product and you get back a number of pages of results. To support something like that, we don't want to render the entire result set on a page because that would take too long and for a variety of other reasons. But databases in general are designed to support that kind of paging mechanism. First of all, it's important to be able to specify a sort on the results of my query. I may be sorting by year, price, or some other feature of my results. And then as I move to page 2, that's likely implemented by another query to the database where I'm skipping, say, the first 10 results and just taking the second 10. Likewise, I may simply limit altogether because I may have millions and millions of records in my collection. I may simply want to limit the number of documents that the database will hand back to me to some reasonable number that my app is prepared to deal with, maybe perhaps several hundred, thousands, or maybe even tens of thousands. Because these concepts of skipping, limiting, and sorting are most important when we're building MongoDB applications, we're going to talk about them now in conjunction with the Node.js driver. So the first one I'd like to look at is sort. Okay, so here we have a version of the application that we've been looking at throughout our discussion of the Node.js driver. And this application takes command line parameters for first year, last year, and employees, allowing us to specify a range of years in which a company in our collection was founded and a minimum number of employees for companies that we'd like to see returned. So just to remind ourselves how this application works, let's go ahead and run it. The one we're interested in running is app-sort, and I'll get my expected usage message. So now let's actually specify command line parameters here. For first year, I'm going to use 2006, for last year, 2009, and for number of employees, 100. I do my query, 204 total documents, and you can see that the years founded 2006, 2008, 2007, 2008, 2009, and so on as I scroll back through. I've set up the output here a little bit so that we can more easily see when our sort takes effect. Note that we're printing the name of the company, and then what year it was founded, and finally the number of employees. Now let's go back to the app and actually impose a sort. And the cool thing about sort, skip, and limit, beyond the functionality they provide to us, is that in the Node.js driver, these are cursor methods that we can simply chain on to our existing cursor object, much in the same way that we did with project. Let's take a look at sorting our results now by founded year. Okay, so let me talk about the syntax of this briefly. To sort, we use the same syntax we use for just about everything else with regard to the MongoDB query language, in that we specify a document. And for sorting, we specify the field to sort on, and 1 if we want to sort in ascending order, so 2006, 2007, 2008, 2009, versus if we specified -1, then we would sort into descending order. So larger values would occur first, 2009, 2008, 2007, and so on. Okay, so we create our cursor object with a call to find, then we specify a project document on that cursor, and finally, a sort. Now, it's still the case that not until we call this for each here, that the driver actually says, oh, I better go get some documents from the database. Instead, it's building up its representation of our query here in this cursor object as we make additional cursor method calls, adding additional detail to the command that we do eventually want to issue to the database. So now let's run this again. And now we can see that our results have in fact been sorted. We have all the 2009s preceded by all the 2008s, preceded by 2007s, and so on. If we change the direction of our sort, the -1, then when we run our query, we can see that now the results are sorted in the reverse order with all of the earlier years appearing last. So that's how we do sort in the Node.js driver, at least at a simple level. But what if we actually want to sort on multiple fields? For example, I would actually like to see these results sorted by year, but then sorted by number of employees. And I think it would be most useful because the kind of thing I'm interested in here is how are companies over the course of their lifetime growing? So companies that were founded in 2006, are there a lot of those that have grown to large numbers of employees versus, say, later years of founding, 2009, 2013, 2015, just to get a sense for how rapidly companies in this database are growing. And again, we're just doing some very cursory exploration here. When we talk about the aggregation framework in other lessons, we'll see how we can really do a rigorous analysis on data sets like this. If I want to sort on multiple fields, there's something that we need to know about JavaScript and the Node.js driver. You can see that here, I was using an object as the value that I was passing to sort. But here, I'm actually using a list or array. The reason for that is because the order in which these sorts are applied is important here. We want to sort first by founded year in ascending order, so 2006 to 2009. or whatever years we specify. And then within each year, sort by number of employees, and we want to do that into descending order. So companies with larger numbers of employees will appear first within an individual year. The problem we run into if we try to pass an object here, again remember object and document, I'm using those two terms interchangeably. If I try to pass an object here, is that it's possible that the fields will be reordered. There is no guarantee of order of fields for JavaScript objects, but the order of array elements is guaranteed. So if I want to make sure that I sort first by founded year and then by number of employees, the Node.js driver allows me to pass an array to sort, and within that array, I specify all of my elements as 2-element tuples with the field I'm interested in sorting on and the sort order as the 2 elements of each of those nested arrays. Let's take a look now at what happens when we use this sort. Going back and running our same command, and we can see that we're sorting now by year in what looks like, sure enough, ascending order. Let's take a look at where 2009 starts here. Note we've got Square with 600 employees appearing first, followed by Foursquare with 170, Urban Airship with 165, and so on. So we are, in fact, sorting our search results by year in ascending order, and then within each year in descending order by number of employees. And just as a side note, we can see that we've got some dupes in this data set, so there's a little bit of cleanup that we could still do. And lots of different companies are contained within this database, beyond the startup companies that we've mostly been talking about. So we've talked about sort. So now let's talk about skip and limit. And in fact, we'll look at all three of these together, skip, limit, and sort. Here is an extended version of this application we've just been looking at. Note that the same sort that we ended up with when we were looking at the earlier version of this application is present here, but we're also going to skip and limit. Now, skip and limit are also cursor methods, and as with project and sort, they merely modify the description of the operation that we want to execute against the database. Calling skip and calling limit do not force a call to the database. It's only in this application, when we call for each here, that we'll send this operation, the details for which we've been building up here, to the database, complete with the query, the projection we've specified, the sort we'd like to see, how many search results to skip, and to what size we'd like to limit our result set. Now, we're taking these skip and limit as command line parameters much in the same way we have done in the past. So I'm not going to go into detail on those, except to point out one thing, and that is that for each of them we're specifying a default value. So if skip isn't specified, we specify its value in the options object that gets passed back from command line options will simply be 0. And limit has a default value of 20,000. I set it at 20,000 because I know there are between 18 and 19,000 documents in this collection. And so a default value of 20,000 means that I could potentially retrieve all of the documents from the collection. One last piece of detail here is that we're not specifying an alias for either skip or limit. So at the command line, we're actually going to have to specify the full skip and full limit labels for these command line options, and therefore have to use a double dash in front of each of them. That's just the way our command shell works. For command line parameters whose names are longer than one letter, you've got to use double dashes in front. So let's take a look at an example of calling this application now. Roughly the same parameters as before. The only difference is I'm putting the lower bound on number of employees at 250. That's just so I have a few less appear in each year. And I'm limiting my results to 10 and actually going ahead and specifying a skip of 0, even though that's the default value, and you'll see why in just a moment. So now I do my query. You can see that if I scroll up, I only got 10 documents back. You can also see that they're all from 2006 because I only requested the first 10 documents. All of the employee numbers are greater than 250. The nice thing about the way this application is set up is that it's very similar to what I was talking about earlier, where you do a search to Amazon, you see 10 results on a page, or maybe 25, and then in order to see results beyond that first page of results, you click a next button on the back end. What's happening is the application is actually submitting another query to the database. Same query, just skip the first 10 if that's how many we have on the page. That's what we're doing here. I can look at the first 10 results, and then I can say, okay, I'm ready for the second 10 now. And the third page, and you can see now from 2006, I'm crossing over into 2007. The fourth page, skipping the first 30 results, and so on. This is because in our application, with these parameters that we're passing in, we are specifying that we want to, in our cursor, skip whatever was passed at the command line and limit our results to whatever limit value was passed on the command line. So this is very powerful functionality that allows us to make the database really work for us. We don't have to keep track of too much state in our application in order to do something like this. We simply need to know how many to skip, for example, if we want to page through results. And there are a number of other ways we can use this type of functionality to our advantage. Now, there's one last thing that I want to talk about, and that is the order in which these things are applied. Imagine if we had a result set and we applied the skip operation before the sort operation. That's almost certainly not what we wanted. For example, if I really want to sort by founded year, but the database actually applied skip first, then I might actually end up missing some of my 2006 results because they were in that group that was skipped before I actually did the sort. One thing that's important to bear in mind is that I can completely reverse the order in which I've applied these to the cursor, run my query, and what happens is I get exactly the same results as I did previously when these were ordered by sort, then skip, then limit. The reason for that is that it doesn't matter what order we apply these constraints to our cursor. MongoDB will always sort first, skip second, and limit third. So that is skip, limit, and sort, or should I say sort, skip, and limit within the Node.js driver.